Good morning. Hope everybody's doing all right today. Welcome to the last day of class. So we are going to go through the final exam review today. That's our only plan. I might skip over certain parts of certain problems just to make sure we have time to get through all of it, at least a different problem type for everyone that you might see on the final exam. So we'll kind of see how much time we've got to get through as much as we can. Don't forget, just a couple of reminders here. If you have not already scheduled your time for the final exam, I posted a reminder in the announcements this morning with the link to do that. Again, it won't take you more than 30 seconds just to go in, select a date, select a time, and you're good to go. But just make sure you do that if you haven't already, so that I make sure I know when people are taking their final exam next week. The other things that are due, don't forget, Test 5 was posted last night at midnight, so you've got until next Wednesday at midnight technically to complete that. If you want to go ahead and get it done earlier than that, by all means, go ahead and get it submitted. And as soon as I get those coming in, I will try to grade them once they come in. That way you're not waiting on those grades, and you can kind of see where you stand in the class before you take your final, if you want to take the test before the final exam. The other thing that is due, though, is the homework on the Chapter 6 material. Again, that's not technically due until Tuesday, but if you want to get it done earlier, if you let me know, I can import that grade. I'm not going to import them all until everybody's done on Tuesday, but if you do finish it early and want to know how that affects your overall grade, let me know, and I'll be happy to put that grade in early for you. Okay. I think that's all in terms of announcements. Oh, the other thing, if you didn't already and you do have time, please complete the teacher evaluation that I posted in the announcements. Again, that just gives me some good feedback of things that I could do better the next time I teach the class. So again, if you have some time to do that, that shouldn't take more than 5 minutes because it's mostly check boxes and then just some room for comments down at the bottom. Okay, so if you have some time this week, I would really appreciate that. Okay. If you want to meet with me at all before you take your final exam, just shoot me an email. I'll be happy to schedule a time with you, next week. Again, class time works because we won't be meeting. Student hours times works. I won't be holding regular student hours, but if you want to meet with me during that time, just let me know and I'll be happy to meet. Okay. All right. Any questions, comments, concerns before we get started? All right, again, this will be our last formal class meeting. No meetings next week. All you have to worry about at that point is making sure your last homework assignment's done, the last test is done, and your final exam's done. Okay, that's all you got left. All right, so let's take a look here at the final exam review. So the first example has 3 different parts. I'm going to try to do all 3 of these because each of these limits is a little bit different. So we want to find the limit as x approaches -3 of x squared plus 3x over x squared minus x minus 12. So if we want to find this limit, what would you do first? Okay, good. So we need to simplify. And how are we going to simplify this? All right, good. So we need to factor the numerator and denominator here. See if we have any common factors that might cancel out. Because as it is, if I plug in a -3, it's going to give me 0 in the denominator. That's why I can't just do a direct substitution up front. What's our common factor in the numerator? Good. So I'm going to factor out an x. That's going to leave us with x plus 3 as my other factor. And then what would the factors of the denominator be? Okay, so we're going to have an x plus 3 and an x minus 4. Perfect. Okay, so there's our factors. Now notice that we do have that x plus 3 on top and bottom. That means I can cancel those out. So these cancel out. So now I'm just looking at the limit as x approaches -3 of x over x minus 4. And so what can we do at that point? Good. Now we can direct substitute, plug in the -3, so that's going to give us -3 over -3 minus 4. And if we simplify that, what do we get? Good. It becomes a positive 3 over 7. And there's our answer. Okay, so whenever you have a rational function, remember we can direct substitute, okay, but only if we don't get an undefined answer. In this case, based off what we start with, that would give us 0 in the denominator. That's all we need to factor first. Simplify your fraction, then we can direct substitute. Any questions on that one? All right, let's take a look at this one. So now we're looking at the limit as h approaches 0, and we've got this rational function again, but again, I can't direct substitute because that would give me 0 in the denominator. So what are we going to want to do first this time? Okay, good. Let's go ahead and multiply out the -5 plus h all squared. So keep your limit, h approaches 0. When we multiply this out now, remember this is -5 plus h times -5 plus h, so you got to use FOIL. That should give us positive 25. We're going to get a minus 10h and then a plus h squared. And then we have our minus 25 that was already there, and that's all over h. All right, so what can we do now? Okay, good. We have a 25 minus 25. That's going to cancel out. So now we have the limit, h approaches 0, of negative 10h plus h squared all over h. Good. Now we can factor out an h in the numerator. And so that's going to give us h times -10 plus h all over h. And because we have the h's in the numerator and denominator, we can cancel those out. And so now we have the limit as h approaches 0 of -10 plus h. And so what can we do at that point? Good. Now we can plug in the 0. That's going to give us -10 plus 0, which is just -10. So again, it just comes down to simplifying the fraction first. In this case, we have to expand out the -5 plus h squared. Then you can cancel out any like terms that you have, factor out whatever you can, and then cancel out any common factors just like before. Any questions about that one? All right, let's take a look at this one now. So we want limit as u approaches 2. We've got a square root of 4u plus 1 minus 3 over u minus 2. So again, I can't direct substitute because that's going to give me 0 in the denominator. So what do we want to do first here? Good, right? So we're going to multiply top and bottom by the conjugate of what we have in the numerator. So in this case, that's going to be square root of 4u plus 1 plus 3. And then we have to do the same thing on the bottom, 4u plus 1 plus 3. All right, so that's going to give us the limit as u approaches 2. So when we multiply the numerators, again, this is going to be FOIL here. The square root of 4u plus 1 times the square root of 4u plus 1, the square roots cancel out, and you're just left with 4u plus 1. Then our outer and inner terms are going to cancel. That's why we use the conjugate. So then we just have a -3 times a +3. That's going to give us a -9. And then down here, we're going to have our u minus 2 times the square root of 4u plus 1 plus 3. And notice I'm going to keep that factored. I'm not going to try to distribute any of that stuff out. And the reason for that is I'm looking for common factors that might cancel out now. All right, so once we combine like terms in the numerator here, what's that going to give us? Okay, good. So we end up with 4u minus 8. And again, I'm going to keep everything factored in the denominator here. And so what can we do at that point? Okay, good. We have a common factor of 4 in the numerator. So let's go ahead and factor that out. So we're going to have 4 times, and that's going to leave us with u minus 2 over u minus 2 times the square root of 4u plus 1 plus 3. All right, what can we do from there? Okay, good. We have a u minus 2 factor in common, so I can cancel those out. And so now we have our limit as u approaches 2, 4 over square root 4u plus 1 plus 3. And so what can we do now? Good. Now we can substitute because that's not going to give us 0 in the denominator anymore. So we'll have 4 over square root of 4 times 2 plus 1 plus 3. And if we simplify all that now, what should we get? Okay, good. So 4 in the numerator, 6 in the denominator. And then we can simplify that even further, right, to 2/3. And so 2/3 would be our final answer here. And so again, just remember, if you ever have a square root in your limit like that, then you can't direct substitute up front, multiply top and bottom by the conjugate, and then you should be able to simplify from there to actually be able to direct substitute. Any questions on that one? And remember, my solutions are also posted to Blackboard, so if you want to look back at any of my work, it's all there for you, okay? All right, so let's take a look at example 2 now. We want to find the derivative here, but using the limit definition of a derivative. Okay, so don't forget, right, we can definitely use the shortcut to check ourselves on this one, okay, but you got to remember that limit definition of a derivative. So limit definition here, we're going to say the limit as h approaches 0, and then we're going to have f of x plus h minus f of x all over h. And so that's the formula we're using here. So we're taking our limit, h approaches 0. Now we need to substitute x plus h into our function up here. So that's going to give us 3 times x plus h squared minus 4 times x plus h plus 1. And then we're going to subtract f of x. So we're just subtracting that entire function, 3x squared minus 4x plus 1. Notice I grouped all that in parentheses because I need to make sure that minus gets distributed to everything there. And that's all over h. And now it's just a matter of simplifying this so we can actually do our direct substitution. So what would you do first? Okay, good. Let's go ahead and square the x plus h. So I'll keep my 3 there. That's going to give us x squared plus 2xh plus h squared. All right. What else can we do here? Okay, good. So I'm going to go ahead and distribute my -4. So we'll get a -4x and a -4h plus 1. We can also distribute this minus now to all of this. So we'll get -3x squared plus 4x and -1 all over h. All right, now to be able to combine like terms, I also need to distribute this 3, so I'll go ahead and do that. 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 1 minus 3x squared plus 4x minus 1 all over h. Okay, so if we combine like terms now in our numerator, what's that going to leave us with? All right, so we'll have the 6xh. We'll have the 3h squared, good. And then we should also have the minus 4h, okay, because our 3x squared and minus 3x squared cancels, negative 4x and positive 4x cancels, and the positive 1 and the negative 1 cancel. And again, that's all over h. And so what can we do at that point? Good. Now we can factor out the h, right? So we'll have limit h approaches 0, h times 6x plus 3h minus 4. All right, and then just like the one before, once we have the h in common, we can cancel that out. And now we can just do a direct substitution, right? So if we direct substitute in here, what's that going to give us? Good, right? Because the 3h just becomes a 0. If you want to see that work, right, it's just 6x plus 3 times 0 minus 4. Middle term cancels out, and we're just left with 6x minus 4. And again, you can always go back and quickly check yourself on this one, right? Because if you just use your power rule here, 2 times 3 is 6. Drop the x, multiply by 1. That gives us the 6x. The minus 4x is just going to give us a minus 4. Derivative of a constant, the 1, is just going to give us 0. So 6x minus 4 is the correct derivative here. Okay, but make sure you know that formula, right? It won't be given to you, and you need to know how to find the derivative using the limit definition. Any questions on that one? All right. So now example 3 is implicit differentiation. We'll probably just do the first part of this one. The second part is going to be very similar. It's just got trig functions in it. But just for the sake of time, we'll just do the first part. So if we want to use implicit here to find dy dx or y prime, however you want to write that is fine. I'll give you credit either way. If we look at that first term, what's the derivative of y to the 5th going to look like? Okay, so we are going to get 5y to the 4th. But because it's implicit differentiation, what else do we have to remember here? That's right. We also need a y prime because we're technically taking the derivative with respect to x. And so when we take the derivative of a y term, we either need a dy dx or a y prime there. Okay. And so here's just a basic power rule. Just don't forget the y prime. Plus, now, what are we going to have to use to find the derivative of the second term? It is a product, right? So we're going to use product rule. So if you want to, I'll come up here. We'll let f be equal to x squared. G will be equal to y cubed. And so what's our f prime going to give us? Good, that's going to be 2x. And what's our g prime? Good. Just be careful there. 3y squared y prime. Good. Okay. All right, so now if we use our product rule again, just remember you're going to need to know these formulas. Fg prime plus gf prime. Start with f. We've got x squared times 3y squared y prime plus, and then we take our g function, which is y cubed, multiply that by 2x. Okay, so there's the left-hand side, just finding the derivative there. All right, now if we move to the other side, what's the derivative of 1? 0, right? So I'll put a 0 in there just to make sure it's clear where that came from. Okay, but just remember, if you have a constant there, it's always going to give you a 0. And then what are we going to have to use to find the derivative for x to the 4th y? Product rule again, right? So again, I'm just going to list out my f as x to the 4th. G is just y. So what's our f prime going to give us? Yeah, that's 4x cubed. And then our g prime is just y prime. Perfect. So again, same product rule formula. So we start with f. That's going to be x to the 4th. We're going to multiply that by g prime, which is just y prime. Then we're going to add the g, which is just y, times the f prime, which is 4x cubed. All right, any questions on that step, just finding the derivative of each of those terms now? All right, so what are we going to want to do next? Okay, good. We need to get all the y prime terms to one side, and everything that doesn't have a y prime, we're going to move to the other side. Let me clean it up just a little bit first. All right, so this first term's okay. 4y to the 4th y prime plus, I'm just going to move this 3 out front. So 3x squared y prime. Same thing here. I'm going to move the 2 to the front and the x in front of the y cubed. 0 can go away. We got x to the 4th y prime plus, bring the 4x cubed to the front here, times y. All right, so I'm going to move all my y primes to the left. I'm going to move everything else to the right. That just means I need to subtract the x to the 4th y prime from both sides. And I need to subtract 2xy cubed from both sides. Okay, so now we've got 5y to the 4th y prime plus 3x squared y prime minus x to the 4th y prime. And now on the other side, 4x cubed y minus 2x y cubed. All right, once we get all of our y primes to one side, now we can do what? Good. And what are we going to factor? The y prime. So take out your y prime here. So that's going to be 5y to the 4th plus 3x squared y squared minus x to the 4th. Right-hand side does not change. Good. And now we can divide by everything in parentheses to get y prime by itself. And so that's going to give us 4x cubed y minus 2x y cubed all over 5y to the 4th plus 3x squared y squared minus x to the fourth. There's our derivative. Any questions on any of the steps for that one now? And just remember, if you happen to move all of your y primes to the right and everything else to the left, all that's going to happen is every one of your signs here would be the opposite of what we got. Perfectly fine, right? It's still equivalent. Okay, you'll still get full credit for that. So it doesn't matter which way you move the y primes. Yes. So exact same types of problems, just with different numbers, right? So number one is going to be, 3 limit problems. Number 2 is going to be a limit definition of a derivative. Number 3 is going to be a couple of implicit differentiation problems. It's going to be laid out exactly the same. Okay. Yeah, so there shouldn't be any surprises, right? Everything, you should be anticipating what's coming on the final exam. Any other questions here? But I will also tell you, be careful. All the tests, there was one version. There's multiple versions of the final. So don't think, oh, I'm going to talk to somebody that took it on Monday and know exactly what the questions are, because you probably won't, right? Because you'll probably get a different version than they did. Okay, so again, types of problems will be the same, but numbers will definitely be different. All right, so now I'm going to skip this one, sorry. So again, that's implicit again, same process. The only difference is there's some trig functions there, right? So you can look at my work in the solutions that I provided if you want to see how to do that one. All right, example 4, we want to find an equation of the tangent line and normal line to the curve at the given point. So if we want to know the equation of the tangent line, what are we going to have to do first? Okay, good. So we need to know the derivative so we can find the slope. So how are we going to find the derivative for this one? All right, good. It's going to be a power rule along with a chain rule. So the first step is, let's go ahead and change this to a power. So this is going to be 1 plus 4 sine of x to the 1/2. Right. So anytime you see a square root and you're taking a derivative, go ahead and change that to a 1/2 power. All right. So like you said, this is going to be a chain rule technically. If you need to write out the u part, that's fine. This would be u equals 1 plus 4 sine of x, which means this is now just u to the 1/2. What's the derivative of our u value going to be this time? Okay, so the derivative over here is going to be 1/2 u to the negative 1/2, and then we have to multiply by u prime, right, since it is a chain rule. Good. Now, what is u prime going to be equal to? Good. That's just going to be 4 cosine x. And now we can put everything back in there. So we've got y prime equals 1/2, 1 plus 4 sine of x to the negative 1/2 times 4 cosine of x. Now, before we actually do any substitution or anything, let's go ahead and just move some things around. The 4 cosine x is definitely going up top. The negative 1/2 power we can move to the denominator, and technically, right, 1/2 times 4 is 2, so we're really just going to have a 2 cosine x here. So we'll have 2 cosine x over 1 plus 4 sine of x to the positive 1/2 power. Okay, or if you want to put a square root there, that's fine too. All right, so any questions there about finding that derivative or how we got that answer? All right, once we have the derivative, now what do we need to do? Okay, good. So we know our x value here is 0. So we're going to plug that value into our derivative. That's going to give us the slope for our tangent line. So we're going to have m equals 2 cosine of 0 over 1 plus 4 times the sine of 0 to the 1/2 power. All right, so if we simplify that now, what's that going to give us? 2, right? Because 2 cosine 0, that's 2 times 1. That's going to be 2 in the numerator. 1 plus 4 sine of 0. Well, sine of 0 is 0, so that's really just 1 to the 1/2, which is 1. And so that all simplifies down to 2 now. All right, now that we know the slope of our tangent line, let's think about our equations. So what's the equation for the tangent line going to look like? Okay, so you can start with point slope form, right? And if you want to rewrite it in slope intercept, that's perfectly fine. So this is going to give us y minus 1 equals 2 times x minus 0, because 2 is the slope. And then if you want to distribute the 2 and move the 1 over, then that would be y equals 2x plus 1. Good. All right, now notice it did also ask us for the normal line. So what do we know about the normal line now? Good. So the slope is going to be perpendicular, right? So it's the opposite reciprocal. So change the sign and flip it. So point is still the same. So we get y minus 1 equals negative 1/2 times x minus 0. And again, if you want to distribute and move the 1 over, it's going to give us negative 1/2 x plus 1. And again, if you stop at point slope form, I'm going to give you full credit for that, right? Because I'm really just looking here, do you know how to find the derivative? Can you find the slope? And then once you know that, do you know that the normal line has the opposite reciprocal or perpendicular slope? Okay. Any questions at all on that one now? All right. Example 5. So we've got the top of a ladder sliding down a vertical wall at a rate of 0.15 meters per second. At the moment when the bottom of the ladder is 3 meters from the wall, it slides away from the wall at a rate of 0.2 meters per second. We want to know the length of the ladder. So what's the first thing you would do here? Okay, good. So let's draw a picture. So what's our picture going to look like this time? Good. It is going to be a right triangle. So I'm going to put my vertical wall over here. We've got the floor down here. And then we've got our ladder leaning up against that wall. Okay, so we have a right triangle. All right, now what information do we know this time? Okay, so we know this length down here, and I'll call this side B. This is going to be 3 meters. Okay. What else do we know? Okay, good. So we know the rate at which the A length over here is shrinking, right? We don't know what A is, but how would you label the rate of change of A in this case? Good, right? So this is a rate with respect to time. So we're going to call that dAdt. And so this is going to be what value for dAdt? Okay, 0.15, but again, you said it was shrinking, right? So what do we have to do to it? Make it a negative. Good. So we're going to have a negative 0.15 as our dAdt value here. So just keep in mind, anything that's getting shorter or shrinking is going to have a negative rate of change, so just make sure that's negative. All right, what else do we know? Okay, good. So what is dB/dt? Good, and that one's going to be a positive 0.2, okay, because that ladder's sliding away from the wall. That length is getting longer in this case. All right. Now we're trying to find the length of the ladder, so we want to know how long is C. So what would you do next? All right, good. It is going to be Pythagorean theorem. So we've got a squared plus b squared equals c squared. And so then we have to do what? Okay, good. We need the derivative of this. Remember, this is going to be implicit because we're taking the derivative with respect to time now. So we'll get 2a times dAdt plus 2b times dB/dt equals 2c times dC/dt. Okay, so just don't forget, with all of these, we're taking a derivative with respect to time, so all of them need that dAdt, dB/dt, or dC/dt. All right, what do you want to do next? All right, so the 2 cancel. So you're just saying you could cancel out all the 2's? Is that what you're saying, Dean? You could, right? It's up to you if you want to do that. You could just divide through the entire equation by 2 because they would cancel. What else can we do now? Good. The rate of change of the ladder, dC/dt, is going to be 0 because the length of the ladder is not changing at all, right? That is fixed. And so whenever you have a fixed length like that, the rate of change of that length is going to be 0. So now we actually have everything we need here to plug in to be able to solve for A, and then we can use that to help us find the C value. So we've got 2 times A times negative 0.15 plus 2 times 3 times 0.2 equals 2 times C times 0. So even though we've got 2 variables there, A and C, the 2C times 0 is just going to become 0. So that goes away. This is going to give us negative 0.3A plus, this is 6 times 0.2 should be 1.2. And over there we get a 0. So if we solve that now, what are we going to get for A? Good. So when we divide here, that tells us that A is equal to 4. We're looking for the length of the ladder, though. So what do we have to do now? Now we can use Pythagorean theorem again, or if you just recognize it as a 3, 4, 5 triangle, you could just say C equals 5 at that point. If you use Pythagorean theorem, we've got 3 squared plus 4 squared equals C squared. That's 9 plus 16, which is 25. And the square root of 25 is 5. Okay, so our C value up here now is going to be 5 meters, and that is our final answer. But again, anytime you see a related rate problem like this, try to draw your picture first, label everything you possibly can in that picture based off of what's given, and then think about what formula you're going to have to use. Take your derivative. Don't forget that you're taking it with respect to time. Plug everything in. Sometimes, right, you'll start to do that and realize you're still missing something, so just kind of go back to your word problem, see if there's anything else. In this case, the fact that dc dt equals 0 is not given information, right, but it is just knowledge, right, that we know because it's not changing, that has to be a 0, so don't forget that. Any questions on that one now? All right. Example 6. Okay, so a box with an open top is to be constructed from a square piece of cardboard 3 feet wide. And we're going to do that by cutting out squares from each of the 4 corners and bending up the sides. We want to find the largest volume that such a box could have. So what do you want to do first? Okay, good. Let's draw the picture. What kind of picture are we going to have this time? Good. We're going to draw a square to start with. Right, so we've got our square. Okay, 4 equal sides there. All right, and then we're going to have smaller squares in the corners, right? So basically, we're cutting out squares from each one of these corners here, and they should all be the same size, so do your best to make them the same. All right, now what? And like I said, it is 3 by 3, right? So we know that this total length is 3. This total length over here is 3. All right. All right, good. So we can call the length of each of our cuts X now, right? Because we don't know how much we're cutting out from each corner, but we do know they're squares, and we know they're going to have to all be the same to be able to fold this thing up and actually turn it into a box. Okay, so each of the lengths of those squares is going to be an X. All right, so that's pretty much all the information we're given now. So what can we do at that point? Okay, good. We need the volume formula for a box, right? So in this case, a rectangular prism. And so volume is going to be length times width times height. And so we need to think about what that's going to look like in terms of this, right? So once we actually do our folding and create our box here, what are the length, width, and height going to be? All right, so the length and the width are both 3 minus 2x, right? Because we're taking the 3 that we started with, we're cutting out 2 squares, one on each side. So that length now is 3 minus 2x. Same thing with the width. That's going to also be 3 minus 2x. And then what's the height of the box going to be? That's right, it's just going to be x once we actually fold these up to create the box. Any questions about how we got that volume formula? Okay, what would you want to do next? Okay, so now that we have that volume formula, what would you want to do with it? Let's go ahead and distribute first, right? Because that's going to make the derivative easier. If you take the derivative here, it's fine. It's just you're going to have to use multiple product rules within the same problem, right? If you distribute it, then it's just power rules. So I would say distribute first. So now we've got 3 times 3 is going to give us 9. Negative 3 times negative 2x and negative 2x times 3, that's going to be negative 6x and negative 6x. We get a negative 12x. Negative 2x times negative 2x is a positive 4x squared. And now we need to distribute the x to everything. So we have 9x minus 12x squared plus 4x cubed. And like you said, we do need the derivative because we're looking for the largest, which means we're looking for a maximum, right? And whenever you're looking for a min or a max, we're going to take the derivative. So what would our derivative look like this time? Good. So we have 9 minus 24x plus 12x squared. All right, now that we have our derivative, what are we going to do? All right, good. And how are we going to find our critical numbers? Okay, good. So set the derivative equal to 0. And now we're going to want to factor this. I would probably start with the common factor of 3 just to get our numbers a little smaller here. So that would leave us with 3 minus 8x plus 4x squared. And if you want to rearrange terms, if that helps you to kind of see how to factor it here, we have 3 times 4x squared minus 8x plus 3. So then what would our factors be for that polynomial? Let's start with a 3. What are the factors of 3? 3 and 1, right? So that's our only option here. So we have to have a 3 and a 1. What are the options for 4x squared? Yeah, so it's either 4x and 1x or it's 2x and 2x. Well, in this case, if I want to get that 8x in the middle, I'm going to have to use 2 and 2 so that I get a 6 and a 2 to give me the 8. So we're going to go with 2x and 2x. And then our signs here are both going to have to be negative so that we end up with a positive 3, but also get a negative 8x in the middle. So it's going to be minus and minus. Okay, now that we have those factors, now what can we do? Good. Set each factor equal to 0, ignore the 3, so just 2x minus 3 equals 0, 2x minus 1 equals 0, and so our critical numbers here are going to be what? Good. Positive 3 halves and positive 1 half. Perfect. All right, now that we have our critical numbers, now what do you want to do? Okay, so we can do a number line. Now, one thing I'm going to show you here, let's think about if these values are both feasible, right? So if our x value is 3 halves, that means that this value here and this value here are 3 halves. Taking out an x from both of those corners now, what's 3 halves plus 3 halves? Okay, well, if we do 3 halves plus 3 halves, that's going to be 3, right? And so it's going to leave us nothing for that side because the side length was 3 to begin with, right? So we know that this one is not going to work because it would just take out too much of our material, right? We wouldn't have anything left to actually make a box out of, okay? Which means that 1 half is really the only value we have to worry about. If you don't even test it, I'm fine with that because at that point we can kind of assume, yeah, that's going to give us the maximum. But if you want to do your number line just to be safe, right, and put 1 half on there, we need something that's bigger than 0, right, because we know we're dealing with actual links here. So don't go any smaller than 0. And we also need to be definitely smaller than 3 halves because we already said that's too big also, right? So now, 1/4 would work. And then over here, you could do 3/4 or 1 would work if you just want to use an easier value. Now, if we do that, though, again, plug that into your derivative. Plugging that in here, we've got 3 times 2 times 1/4 minus 3, 2 times 1/4 minus 1. Both of these are going to be negative now, and so overall that's going to come out as a positive. And then if we do 1, we've got 2 times 1 minus 3 and 2 times 1 minus 1. First one's going to be negative, second one's going to be positive, so overall that's a negative. And again, what that tells us is this is where the maximum would occur because it goes from increasing to decreasing. But again, even if you don't show me the number line on a problem like this, since 1 half is the only one that's even feasible, just assume that 1 half is the one that works, okay? All right, now, that's not the final answer because we want to know the largest volume that we could have. So what are we going to have to do at that point? Okay, good. We need to plug that value that we got back into the original volume equation that we started with. So we're going to have volume equals 3 minus 2 times 1/2 times 3 minus 2 times 1/2 times 1/2. Okay. And you could have plugged it in to this version right after you've distributed if you wanted to. However you want to plug it in is fine. In this case, I think it's probably easier to use the factored form because the numbers are smaller. 3 minus 2 times 1/2 is just 3 minus 1, so that's going to be 2. Same thing with the second one, that's 3 minus 1, which is 2, times 1/2. And so overall, what's that volume going to give us? Good, so that's going to be 2. And then don't forget your units here. So what are the units going to be for our volume? Good, cubic feet. So we have 2 feet cubed. That would be the answer. Okay, now, obviously, just like your test, right, there is partial credit for problems and things like that. So, showing the picture, getting the setup with the correct equation, finding your derivative, all of those things are going to give you some points. So even if you mess up, and forget to find the volume or you have the wrong value down here, so long as you show me some steps along the way, I can still give you some points for that. Any questions on that one? All right, let's take our break here. So it's 11:58. So or sorry, 10:58. We'll say 11:03. We'll get started back up and finish up the review. All right. So example 7. So we want to find intervals of increase and decrease, extreme values, and intervals of concavity along with inflection points here. So what's the first thing we're going to have to do if we're looking for all that information? Okay, good. We need our first derivative, right? So let's start with that. How are we going to find the first derivative for this problem? It is a quotient. Good. So we have to use quotient rules. So remember, your numerator is your f, your denominator is your g. So we'll say f is x minus 1. G is going to be x squared. So what's our f prime? Just 1. Good. And g prime is going to be what? 2x. Perfect. Okay, and don't forget, for quotient rule, start with g. So it's g times f prime minus f times g prime all over g squared. All right, so if we do that, that's going to give us x squared times 1 minus x minus 1 times 2x all over x squared squared. All right, so let's go ahead and simplify what we've got up here now. And then we'll think about how we're going to find those increasing and decreasing intervals. So this is going to be x squared. Over here now, if I distribute the negative and the 2x, that's going to give us a minus 2x squared. Again, distributing the negative and the 2x, that becomes a positive 2x. And down here now, we're going to have x to the 4th power. And if we combine like terms, x squared minus 2x, it's going to give us a negative x squared plus 2x over x to the 4th. All right, now that we have our first derivative, what can we do next? Okay, and what are we setting equal to 0 here? Okay, so I agree with that, right? But do we only need to worry about the numerator and the denominator, right? Because we need to worry about where it's equal to 0, but also where it's undefined, because those could all be critical numbers. So make sure you're setting numerator and denominator equal to 0 this time. So we have negative x squared plus 2x equals 0, and x to the 4th equals 0, right? All of these are going to give us critical numbers. All right, so how are we going to solve that first one? Okay, and what's our common factor going to be? Yeah, just x, so that leaves us with negative x plus 2. So then we can just set each of those equal to 0, so we get x equals 0, negative x plus 2 equals 0. X equals 0 solved. What are we going to get for the other equation? Good, positive 2. And over here now, we can just take the 4th root, but if we do that, that still gives us x equals what? 0 again, right? Okay, but just don't forget, right? We need to worry about where it's equal to 0, but also where it's undefined. So just make sure, because sometimes you'll get different values from the denominator than you do from the numerator. All right, now that we have our critical numbers, now what can we do? Okay, good. Now we can set up our number line. Our only two values this time are 0 and 2. Again, this is our first derivative number line. So what value would you like to test for that first interval? Okay, negative 1 works. Again, we're plugging that into the first derivative. Probably the easiest place is down here in this simplified version. So we've got -1 squared plus 2 times -1 all over -1 to the 4th. Well, -1 squared is 1, plus 2 times -1 would be a -2. So is the numerator going to be negative or positive? It's going to be negative, right? 1 plus -2 is a negative value. And the denominator here, -1 to the 4th, is going to give us a positive. Perfect. Negative over a positive then means that's all going to be negative down there. All right, what's a value now between 0 and 2 that we could test? 1 works. So again, I'm going to come back over here. I'm just going to change these values to 1s instead. Denominator is still positive, right? 1 to the 4th. 1 squared plus 2 times 1, is that going to be positive or negative? That's going to be positive, and so everything in here now should be positive. And finally, we need something bigger than 2. 3 is good. So again, I'm just going to change these to 3s now. Oh, sorry, this was supposed to be a negative. I messed that up. I apologize. It doesn't change anything about what we got for the other two, though. They're both negative and positive. But in this case, if we do this now, -9 plus 6 is going to give us a what? Okay, good. That's going to be careful. So remember, we're making this a negative. I left that off before. Okay, and so that's actually going to be a negative up top, positive still in the denominator, right? And so overall, that one should be a negative. Yeah, so that was my fault. I accidentally left off the negative to begin with. All right, now that we have all of our signs there for our number line, let's talk about increasing and decreasing. So where would this function be increasing? Okay, good. Only from 0 to 2, that's the only increasing interval because that's the only place it's positive, which means our decreasing intervals are the other two where it's negative. So that's going to be -infinity to 0 and 2 to infinity. Now, the other thing we're asked for is extreme values, meaning mins and maxes. Okay, so do we have any min or max values this time? Okay, and so what do we have? All right, now be careful. Can we have a minimum or maximum at 0? We can't, right? Because if you look back at the original function, 0 would make this function undefined. There's actually an asymptote there. So yes, it still switches from decreasing to increasing around that asymptote, but there can't be a min or max there. Okay, so ignore the 0. 2, though, is fine, right? It's part of our domain. It does go from increasing to decreasing, which means we're going to have what at 2? There's going to be a maximum there, right? And I'm not worried about whether you call it local or absolute, right? It's technically going to be both in this case, but we are going to have a maximum at x equals 2. And then if you really wanted to, it does ask for values, right? So we do need to find the corresponding y value. How are we going to find the y value that corresponds to that x value? Okay, good. So it is 1/4, right? We have to plug that back into the original f of x equation. So we're looking for f of 2. It's going to be 2 minus 1 over 2 squared, and that's just going to be 1 over 4. Okay, so our point here would be 2 1/4. That would be our maximum. All right, any questions about increasing, decreasing, or mins and maxes for this one? Okay, now we need to find concavity and inflection point. So what are we going to have to do next? Good. Now we need the second derivative, right? So I'm going to go to a new slide so we can do that. All right, so I'm just going to write down our first derivative so we have that to work with. And so we ended up with, sorry, I'm looking for it, negative x squared plus 2x over x to the fourth. All right, so how are we going to find our second derivative now? All right, good. It's another quotient rule, so we'll do f is negative x squared plus 2x. G is x to the fourth. All right, so what's our f prime going to be this time? All right, good. Negative 2x plus 2. And g prime is going to be what? Four x cubed. Good. All right, so same formula we just used to find the first derivative. So f double prime, we start with g, that's going to be x to the fourth, times f prime is negative 2x plus 2, minus, and then we have our f function, which is negative x squared plus 2x, times g prime, which is 4x cubed, all over x to the fourth squared. All right, same thing. We need to clean up the numerator here. So we need to distribute combine like terms. So that's going to give us a negative 2x to the fifth plus 2x to the fourth. Down here now, the double negative becomes a positive. We're distributing the 4x cubed, so that's going to be 4x to the fifth. And then the negative in the 4x cubed is going to give us a minus 8x to the fourth, all over x to the eighth. Now, one thing I will point out, you could have actually simplified the first derivative by taking out an x and canceling it first. That might make this a little easier because your exponents wouldn't be quite as large. Still going to be the same basic process either way. But if you wanted to factor out that x first and cancel it out, you could. All right, now, if we do this, combine like terms, we have negative 2x to the fifth plus 4x to the fifth. That's going to be 2x to the fifth. 2x to the fourth minus 8x to the fourth is a negative 6x to the fourth. And all of that is over x to the eighth. All right, any questions on finding that second derivative? Okay, now that we have it, what are we going to do now? Good, set it equal to 0. Same thing, we need to know where is it 0, where is it undefined, so do the numerator and denominator. So we're going to have 2x to the fifth minus 6x to the fourth equals 0, and x to the eighth equals 0 also. What's our common factor this time? Good. We have a 2x to the fourth in common, so we can factor that out. It's going to leave us with x minus 3. And now if we set each of those equal to 0, 2x to the fourth equals 0 is just going to give us what? just 0, right? Because divide by 2, take the 4th root. This other one's going to give us x equals positive 3, and then the 8th root of 0 is still just 0. All right, now that we have our numbers, now we can do our number line. Again, this is our second derivative. We have 0, we have 3. Okay, so what value do you want to test first? Negative 1's good. So again, I'm plugging into my second derivative right here. So we're going to have 2 times negative 1 to the 5th minus 6 times negative 1 to the 4th all over negative 1 to the 8th. And the denominator is definitely positive because it's an 8th power. If we do 2 times negative 1 to the 5th, it's going to be a negative 2 minus 6 times negative 1 to the 4th. That's going to be minus 6. So is that going to be positive or negative? Should be negative. Good. Negative over a positive means we're going to get a negative down there. All right. Then we can test 1. Good. So again, I'm just going to change these values in here now. Again, denominator still positive. 2 times 1 to the 5th minus 6 times 1 to the 4th. Is that going to be positive or negative? Still going to be negative, right? So that's 2 minus 6, still a negative. Negative over a positive, still going to be negative there. All right, and something bigger than 3. We can go with 4. Good. So if we change all these now. Again, denominator is definitely positive. 2 times 4 to the 5th minus 6 times 4 to the 4th. Feel free to use a calculator. So does that come out as a positive or a negative? That should be positive. Good. And so positive over positive is going to be positive there. All right, now that we have our signs, now we can talk about concavity. So let's start with concave up. What interval or intervals where would this be concave up? Good. Only 3 to infinity. That's the only place where we get a positive value. And so that's going to be our concave up interval. That means everything else is concave down. Notice here, 0 is still undefined, so we still need to split our interval there. Don't just go from negative infinity to 3. So we're going to go from negative infinity to 0, and then from 0 to 3. All right, any questions about concavity? Okay, now the last piece is our point of inflection. Do we have any points of inflection this time? At 3, good. So it goes from negative to positive there. So at x equals 3, there is a point of inflection. If you at least give me that, I'm good. If you want to know the actual point, obviously plug it back into the original equation. And if you do that, I've got it written right here so I can tell you. I think I do. Maybe I don't. Nope, I didn't actually do it on my answers either. Okay, so if you wanted to know it, though, you would plug it back in to x minus 1 over x squared. So f of 3 is going to be 3 minus 1 over 3 squared. So that's going to be 2 over 9. So 3 2/9 would be your point of inflection. But again, if you at least give me that it's at x equals 3, there's a point of inflection, I'm good with that. And that's everything you got to find there. So any questions about finding increasing, decreasing, mins and maxes, concavity, or points of inflection? Did I say there was an inflection point? Yeah, so ignore that. Sorry. I think I meant to put that those are critical numbers, and I accidentally put I instead of C. So yeah, those are your critical numbers to test for your number line. But yeah, the only point of inflection there should be at x equals 3. So thank you for pointing that out. Any other questions there? All right. Example 8, we have a particle moving according to the given data. We want to find the position of the particles. We're looking for the position function, and in this case, we're given the acceleration function. So what are we going to have to do first? Okay, good. So we've got to work backwards now. We're going to find our antiderivative. If we find the antiderivative of acceleration, that's going to give us what? Velocity, right? So the first thing we have to find is v of t. So what is the antiderivative for 3 cosine t minus 2 sine t? All right, so it is going to be 3 sine of t. And then this is going to become plus because it's going to be minus 2 times negative cosine of t. All right, so just remember the antiderivative for cosine is positive sine, antiderivative for sine is negative cosine, and then once we simplify that, we do get 3 sine of t plus 2 cosine t. All right, now that we know the antiderivative, we know the velocity, what can we do at that point? Oh, and I forgot, what else do we have to remember here when we find that antiderivative? Don't forget your plus c, right? That's going to be important. Okay, so whenever you're finding an antiderivative, there is an arbitrary constant there. Now that we know that velocity function, now we can do what? Okay, good. We're going to plug in the values that we know. So we know that v of 0 equals 4. So we're going to say, well, that means that our v of t value is 4 here. And then our 0 is the t value. So that's going to be 3 times the sine of 0 plus 2 times the cosine of 0 plus c. Now, if we simplify this, what's the sine of 0? Sine of 0 is 0. Good. Cosine at 0, though, is 1. And so now we're going to end up with 4 equals 2 plus c. And so what's our c value? Good. Just subtract 2 on both sides, so c is 2. All right, so now we've got a velocity function, v of t is equal to 3 sine of t plus 2 cosine of t plus 2. All right, now that we know that, what can we do from there? Good. Now we can find our position function. So s of t equals, now we need to find the antiderivative again. Good. So what's the antiderivative for 3 sine of t? Good. That's going to give us a -3 cosine of t plus 2 sine of t plus 2t, and then some other constant, so we can call that d. Okay, now just like we did with the v of 0 equals 4, we also know now that s of 0 equals 0, so we can plug those values in. So we have 0 equals -3 times the cosine of 0 plus 2 times the sine of 0 plus 2 times 0 plus d. What are we going to get here on the right-hand side? Good. So -3 times cosine of 0 is -3 times 1, so that's a -3. Everything else is just 0, so we have -3 plus d. And so what's our d value going to be? Good. Just move the 3 over. D equals 3. Now we have everything we need. So our position function s of t is going to be -3 cosine of t plus 2 sine of t plus 2t plus 3. Okay. Any questions on the steps for that one? All right. Example 9. Okay, so we've got 3 derivatives here to calculate. So our first one is f of t equals tangent of 1 plus e to the 2t. And like I told you before, these are the types of derivatives you can expect to see, right? Because like this one has a trig function in it. It has an exponential function in it. It's going to test whether you understand chain rule also. So think, you're looking for problems, if you're looking for extra practice, that involve multiple parts, right? Multiple steps and different types of functions. All right, so if we want to calculate this derivative, how are we going to start? All right, good. So let's do u substitution. We'll let u equal 1 plus e to the 2t. I'm just going to rewrite this now as tangent of u. And so just in terms of u now, what would our derivative be? Good. So we have secant squared of u. And because it's a chain rule, we have to have that u prime. Okay, so let's come back over here now and see if we can find u prime. So what is u prime going to look like? It's technically another u substitution, right? Let's see if we can do it without actually writing out a separate u value here. We know the derivative of 1 is just 0, right? The derivative of e to the 2t, if it's e to some power, it's going to start with e to that power, and then we just need the derivative of that exponent. What's the derivative of 2t? just 2, right? So I think this one's hopefully simple enough, right, that we don't actually have to write out the u value in the u prime. Okay, so just remember it's e to the 2t times the derivative of the exponent, and that's how we get that. Okay, so this is u prime equals 2e to the 2t. All right, now we've got everything we need. Just plug it back in for your u and u prime. So our derivative here is going to be secant squared of 1 plus e to the 2t times 2e to the 2t. And honestly, that answer right there is perfectly acceptable. If you want to move your 2e to the 2t out front or something like that, that's fine too. Okay, but as long as you've got this right here, that's perfectly acceptable. So again, just make sure you review those derivatives for trig functions, especially the ones that we don't use as often, like tangent and secant and things like that, because those could come up. And then again, make sure you know how to do u substitutions. Make sure you review your exponential functions, how to find those derivatives, because all of those things could be on there. All right, let's take a look at this one now. So again, we're trying to find the derivative. We've got square root of 1 plus xe to the negative 2x. So what would you do first here? Okay, let's go ahead and change that to a 1/2 power. Good. So we got 1 plus xe to the negative 2x raised to the 1/2. All right, what do you want to do next? All right, it is going to be a power rule combined with a chain rule, right? So your u value is just going to be everything that's inside there. So we got 1 plus xe to the negative 2x. And so if we rewrite this just in terms of u, this is just u to the 1/2. And so using our power rule, we get 1/2 u to the negative 1/2 times u prime. All right, so now how are we going to find the derivative of u? It's actually a product rule, right? The one we can ignore because that derivative is 0, but then we have x times e to the negative 2x. There's a product there. So we got to say, well, let's let f be x. We're going to let g be e to the negative 2x. F prime, hopefully we all know that's 1. What's our g prime going to be this time? Okay, so there is going to be a negative 2 there, and then e to the negative 2x, right? So we have derivative of the exponent is negative 2, and then e to the negative 2x. Okay, so overall now, u prime, like we said, it is going to be a product rule, so start with your f function, so x times g prime negative 2e to the negative 2x plus e to the negative 2x times 1. And then I'll go ahead and clean that up a little bit before we put it over here. So we have negative 2x e to the negative 2x plus e to the negative 2x. Any questions about finding that u prime value using our product rule now? Okay, so now we can just put all that back over here. So we've got y prime equals 1/2. U value was 1 plus x e to the negative 2x. That's being raised to the negative 1/2 now, times u prime, which is negative 2x e to the negative 2x plus e to the negative 2x. So then the last thing I would do here, right, let's move the negative 1/2 power to the denominator with that 2. All this other stuff can go up top. So y prime equals negative 2x e to the negative 2x plus e to the negative 2x over 2 times 1 plus x e to the negative 2x to the 1/2. And again, if you want to change that back to a square root, you can. You could also factor out e to the negative 2x in the numerator. Not that it's going to cancel with anything, so it's not necessary. But as long as you got something like that. Now, don't worry about getting rid of the negative 2x powers, right, on all the e's, because notice the original equation had that negative 2x up there anyway, so I'm fine with you leaving that one. Okay, so just move the negative 1/2 to the denominator, though. Any questions on that one? All right, last derivative problem. H of x equals natural log of x plus the square root of x squared minus 1. All right, so what do you want to do first? Okay, so we're going to let u be everything on the inside again. So that's x plus, I'm going to go ahead and change this to a 1/2 power. So x squared minus 1 to the 1/2, which means our original function now is just natural log of u. Now, just in terms of u, what would our derivative be? So what's the derivative for natural log of u? Good, just 1 over u, right? So this is 1 over u, and then again, it's a chain rule, so just don't forget your u prime. So now we need to come over here and find u prime. And what's the derivative for x? That's just a 1, right? So we're going to get 1 plus. And now over here, this is going to be a power rule combined with a chain rule. If you need to write out a separate u substitution, feel free. I think we can probably do it without it, though. I'm going to bring down the 1/2. I'm going to keep the x squared minus 1. I'm going to subtract 1 from my exponent, and I'm going to multiply by the derivative of the inside. And what is our derivative for the inside? Just 2x, right? Okay, so there's our derivative this time for u prime. And if you want to rearrange some terms here, 1/2 times 2 is just 1, so this really just becomes x times x squared minus 1 to the negative 1/2. Right, now we can just put everything back in here. So h prime of x is going to be 1 over the u value, x plus x squared minus 1 to the 1/2 times everything we got over here now, 1 plus x times x squared minus 1 to the negative 1/2 And so now if you want to, we can put all that stuff up here in the numerator. So 1 plus x times x squared minus 1 to the negative 1/2 over x plus x squared minus 1 to the positive 1/2. And so the only thing I don't like about this answer right now is that negative 1/2 as my exponent. What could we do to get rid of that? Okay, good. So just multiply top and bottom here by x squared minus 1 to the positive 1/2. That way we can cancel out that negative exponent. So if we do that, just remember you're distributing it to both of your terms here. So that times 1 is going to be x squared minus 1 to the 1/2. When we distribute it to this term now, those cancel out, and so we're just left with a plus x. And then down here, again, distribute it to both terms. We're going to have x times x squared minus 1 to the 1/2. And then when we distribute it to this one, it just becomes plus x squared minus 1 to the first power, or just x squared minus 1. And I'm good if you stop there. There's a lot more simplification you could do here, and I put what you could simplify it down to on my answer key there. It's 1 over square root of x squared minus 1. Not that I would expect you to go that far. Just don't leave the negative exponent. That's the main thing there. Okay. Any questions on that one? All right, so now we've got 4 minutes left. I'm going to get through as many of these integrals as I can. Let's see what we can do with this one first. So we've got 2 plus x squared over the square root of x. And just for sake of time, I'm going to go ahead and show you what I would do. Start by simplifying this. And what I mean by that is we've got 2 plus x squared over x to the 1/2 power. And so because there's only one term in the denominator, we can actually just divide each of our terms by x to the 1/2, which is going to give us 2x to the negative 1/2 plus, and then when we subtract exponents over here, it's going to give us x to the 3/2. So whenever you got a fraction like that, if you can simplify it, that's what you're going to want to do, because now it's just a power rule, right? So now we can find our antiderivative. Remember to do that, we're going to raise our exponent by 1, divide by the new exponent. So I've got 2 times, this becomes x to the 1/2 divided by x to the 1/2, which is actually just 2. If we raise our exponent by 1 here, that's going to give us 5/2. Divide by the new exponent, that's the same thing as multiplying by the reciprocal, so 2/5. And this is being evaluated from 1 to 4. Okay, so 2 times 2 is 4, and now we're substituting in here. So we've got 4 times 4 to the 1/2 plus 2/5 times 4 to the 5/2 minus 4 times 1 to the 1/2 plus 2/5 times 1 to the 5/2. Again, just for sake of time, right? You would put that in the calculator, you would get your final answer. And if you simplify all of that, it should give you 16.4, or if you prefer the fraction, 82/5. Now, remember, this is also one that if you have a graphing calculator, you could graph the original function and then actually go to second trace, go down to your integral, put in your lower and upper bounds, and it'll actually give you 16.4 as the area under that curve. Okay, so there is a way to check this one. I definitely want to see the work, right? But if you want to check yourself on one that's a definite integral, you can use the calculator for that. All right, now I know we're low on time. If you need to drop out, I'm going to try to at least do part D here, just to give you one other type. So we've got cosine x over 2 plus sine x dx. So this is going to be a u substitution type of integral. What would you want to let u be equal to on this one? Okay, good. Let's let it be equal to the denominator. So u equals 2 plus sine of x. So when I start to rewrite this now, I'm going to have u in the denominator, which means I still need to replace what? The cosine x and the dx, right? So I'm looking for this now. Well, let's come over here. Du dx is going to be equal to what this time? Just cosine x. And so if I move the dx to the other side, now I have du equals, oops, sorry about that, cosine x dx. And so now when I replace this, the cosine x dx all just becomes du. And now I just need a 1 up here in my numerator. So we're really just integrating 1 over u du. Well, what's the antiderivative for 1 over u du? That's a natural log. Good. So we get natural log. Remember, with the antiderivatives, we need the absolute value. So don't forget that piece. And then because it's indefinite, don't forget your plus c. Now we just plug in the u value. So we have natural log, absolute value, 2 plus sine of x plus c. And technically for this one, sine of x is between -1 and 1. So if we add 2 to that, it's always going to be positive anyway. So even if you were to drop the absolute value bars on this one, it would still be correct. Okay, so again, up to you. If you stop at the line before, right, I would take either one of these answers. But again, technically, the absolute value bars are not necessary because that value is always going to be positive anyway. So again, just make sure, review how to simplify things inside of integrals, because sometimes that's going to be your best bet. If that doesn't work, then look for ways that you can do u substitutions and then figure out how you can get everything in there that you need to find the antiderivative. All right, so that's the final exam, right? I mean, I know we skipped over like one part of number 3 and 2 parts of number 10, but as long as you go back and review all those different types, I think you'll be okay. Again, if you need to meet with me for some reason, just let me know. I'm more than happy to meet. I'm not going to have any set office hours or anything, but just email me and let me know if you want to meet sometime next week before you take your final. Don't forget the due dates, because again, we're not going to be meeting next week. Tuesday is the homework, Wednesday is the test. Feel free to do them earlier. If you do them earlier, please just, and you want to know your grade faster, just email me to let me know you've already submitted it. That way I can get your grade updated, and you'll kind of know where you stand going into the final exam. Okay. The other thing is, if you do that and you want to know what you would need on the final to maintain a certain grade, I'm more than happy to do those calculations for you also. But again, I need the final homework and the final test to be able to tell you that. Okay. I think that's all I've got. Let me know if you've got any questions. Let me know if you want to meet. It's been a pleasure teaching you all this semester. I hope you do well in the final exam. Good luck with any other exams you're taking. And maybe I'll have the pleasure of teaching some of you again in the future. So have a great rest of your summer. Good luck, and I will see you later.